-3b, part B. We're going to look at, let's see, yesterday you did double angle formulas, half angle formulas, and lowering powers formulas. Today is about product to sum formulas. Sine and cosine, if they're multiplied together, you can change them into an addition or subtraction problem. And then vice versa, if you have a sine and cosine that's added together, you can change them into products. Okay? So for the same reason, or the same analysis here, if I gave you a standard equation in algebra, 2x plus 4x equals 17, and I said, you know, put that into slope-intercept form. It's not that you couldn't use the standard form to graph it or come up with some other thing that we needed. It's just the fact that you've learned a useful tool to manipulate the way the equation looks so that you can use it for different things or be able to solve it in a different way. That's the same thing with what we're doing with trigonometry. Given certain expressions and equations, we are using different identities and formulas to change the way it looks. It's not that you can't use what has been given to you, it's that you can change it to make a problem easier if necessary. So you're learning a process. Alright? Alright, so more formulas. Now in chapter 8 we don't have a lot of formulas to put in your reference sheet. So if you feel like you got a lot in your reference sheet, relax. I mean, we still have 2 more sections to go, you're gonna put some more on it. But chapter 8 there's hardly anything to put in it. Okay? Alright, let's look at a problem here. Let me just grab one. Let's do, I'll just pick one out of here. Let's do product to sum. Sine of x, sine of 5x. This is number 56. Sine of x times the sine of 5x. Now, again, just like in algebra, when you have an x and a y in an equation, you can't really solve it for x and y unless you have more information, but you can manipulate the way it looks. The same thing goes here. I don't know what the x value is, but I can manipulate what I have here. I have something times something else. And in so doing, you have a product formula where the sine of u times the sine of v, and this is in your book, this is the last formula in that section. It's 1/2 times the cosine of u minus v minus the cosine of u plus v. Alright, they're just positions. That's your u and that's your v. And you just plug the information in. Again, you don't know what x is, so you're not solving this. You're just going to put it into the formula and simplify if you can. So it's 1/2 cosine, u is x, v is 5x, so x minus 5x is negative 4x, minus the cosine of u plus v, so that's 6x, and you've learned that your negative sign can come out in front here. If you wanted to, you could put that out in front and say cosine of 4x. This is all you would need to do for the test. We don't know what x is, so there's nothing really left to simplify except maybe putting this out in the front of the cosine. Okay. Plugging in these positions where u and v are in your formula. That's all it is. So what you should recognize is, given a problem, you should recognize, well, that's 2 sine functions, sine concepts being multiplied together. So it's the product being changed into an addition or subtraction form. Now let's do one with something in it that we can use, okay? So let's do, I'll try to do something that's simple here. This is number 68. This is 3 times the cosine of 37.5 degrees times the cosine of 7.5 degrees. Now, I immediately look at that and I say, it is a product. Nothing else I can do with it. Granted, you could take your calculator and plug this in and give you a value. That's not the point of what you're doing. Okay? If I want to change this into a sum, which means in this case addition or subtraction, I find the cosine times cosine form that's on here. Okay? So it's going to be 3 times whatever this is. Cosine times cosine, that's going to be the third one on your list, is going to be 1/2 times the cosine of u plus v. That's u and that's v. What's 37.5 plus 7.5? 45 degrees. So it's the cosine of 45 degrees, which you all should know. Plus the cosine of u minus v. What's 37.5 minus 7.5? 30 degrees. Okay, I know you're all writing. This is quite fast. But hopefully you're looking at your formula and you can catch on. So far so good. And over here, we stayed there. We were done because we couldn't do anything. But here, don't you know the cosine of 45 degrees? What is the x value at 45 degrees? Yeah, so I have 3 halves out in front times radical 2 over 2. What is the x value at 30 degrees? Radical 3 over 2. So that should be something, when I ask you that type of question, what's the cosine at 60 degrees, you should be able to fairly quickly tell me that stuff. And if you need, you can circle out and get it out and make sure you have it out and have it. But you can't have it on the quiz, you can't have it on test. So we've drilled that into you, hopefully by now you got it. But those are answers you should be able to think of, and within a second or two give me the answer. Okay, so it's either a 30-degree triangle, a 60-degree triangle, or a 45-degree triangle that I'm referencing. That's why it's important when I gave you those test questions last chapter about reference angles. You should be good at telling me what a reference angle is. And then you multiply this out. So 3 halves times radical 2 over 2 is 3 radical 2 over 4. Plus 3 radical 3 over 4. And then again, you can just say, you can write it like this. That'd be fine. Could have left it like 3 radical 2 plus 3 radical 3. Okay. That part doesn't bother me, but you got to make sure that it's combined. Okay. Any questions on that? So that's taking a product of a trig function, 2 trig functions, and making them into addition or subtraction. Here's the algebra example, and here's the example with numbers. And then we can do another one. Let's go the opposite direction. Let's do a sum of trig functions and turn them into products. So this is the second part of your formulas. And I'll just, instead of doing the algebra part by now, I'll pick a problem that we can actually figure out. So let's take number 70. Number 70 is the sine of 75 degrees plus the sine of 15 degrees. Now, I know you can tell me on a calculator what the sine of 75 degrees is and what the sine of 15 degrees is, and you can add the two together. That's not the point of what we're doing. We're learning a skill, being able to manipulate the trig functions. Alright, so you have your, if you don't have, I assume you don't have these written down, so you have your books open to what those formulas are. You should look at this and say, this is an addition of trig functions. I will be able to make this into a product. Different than the addition and subtraction formulas that you learned the other day. Addition and subtraction formulas, you had sine and cosine multiplied together plus sine and cosine multiplied together in some form. You don't have that here. You just have a sine plus another sine. That's how you can tell that you need to make this into a product. Alright, so sine plus sine. It is the first one on your formula sheet. It is 2 times the sine of 75 plus 15 over 2 times the cosine of 75 minus 15 over 2. And all I did was substitute the values in those positions into the formulas. Okay, again, this section was all about just transferring into formulas. That's really what it was about. So what's 75 plus 15? What's 90 divided by 2? Okay, sine of 45 degrees, we know. What is 75 minus 15? 60. What's 60 divided by 2? 30. And we know these values. Again, the y value at 45 degrees, square root of 2 over 2. So we have 2 times radical 2 over 2. What is the x value at 30 degrees? Radical 3 over 2. So here we have, those will cancel out, we have radical 6 over 2. And if you did that in a calculator, you get the same thing as if you took the sine of 75 plus the sine of 15. Okay? So that's the product to sum formula and the sum to product formula. See, here's the product. Same type of thing. Any questions on that? So your assignment that I want you to do, in addition to what you did, if you didn't get it done, make sure you finish it, is page 515. And do 55 to 71 odds.